Last check, I'm going to go over real quick. I know we're over time. If you injection mold a part that's thick like this, plastic injection molding, two bad things can happen. It's either going to sink when it cools, this thick section, or a void's going to develop on the inside. Both of these are bad. If possible, you want to find your part, your plastic injection molded part to look like this. That's good. But how do you know? You're not a plastic mold engineer, and you want to make your part the best it can be. How do you figure this out? I tried to look in Lowe's, Home Depot, Walmart for parts that had sink marks in them, for parts that had material defects for the plastic injection molding, and I couldn't find them. Why? They had already been taken out by the design process. Someone had caught them somewhere in the design process. So I found this picture online. This is a sink mark. This is a top example here. You can see it right there. The part was too thick. Maybe there's a void. It sunk after it cooled. So someone in the product line has this responsibility to catch these problems. Maybe it's a mold engineer. Maybe it's a quality assurance guy, right? Someone has the problem, because I couldn't find anything in Lowe's that had this problem. Why do you care about it as a design engineer? I told you you'd see this Cooper rework cycle again. And you've got a bunch of work to be done. It goes through a gate depending on how many people you throw at it. But you find problems along the way, and that feeds back to the top of the funnel. We talked about it last time. Which one is the project killer? That one right there. The work you have to redo that you didn't know about. When do people find, Al, I'm going to ask you a question. When do people usually find problems with their injection molding?
After they've already started the molding process and built all their tooling.
Exactly. Way, way late in the design. If you want to stop this Cooper rework cycle from killing your designs, you want to find them early, you want to know about them, and you want to make your molds right the first time, right? Especially for consumer products, you guys want to release a product usually once a year, usually before Christmas. You don't have time to send it back to the mold shop 3 or 4 times, right? You need this check to pass, and maybe you want to do it in-house, but you need this check to pass the first time. So what can we do about it? New in 2012, there's a SOLIDWORKS module called Plastics, right? What does it let you do? Take your SOLIDWORKS part, right, and it lets you simulate the mold filling process. This is different from all the other types of simulation we did before. You're simulating the actual molten plastic going through your part. Now, what's wrong with this picture? As I keep playing it, right, it looks like everything's filling up. Watch these fins right here, these ribs. Do you see how the two wave fronts are running into each other? Right? One wave is coming from one way, another wave is coming from another way, right? That's bad. Those are two wave fronts that are cooling, running into each other, and trying to meld and trying to make a bond. That's very bad. They call that a weld line in molding. Right? The plastics module in SOLIDWORKS lets you point out those weld lines. And it's the only simulation package where blue is very, very bad. Usually red is bad. In this case, blue is very bad. So again, look at all those weld lines right here, right here, right here. Okay? Weld lines are bad aesthetically. They'll drive your industrial designer crazy. They're also bad mechanically. They tend to be the weakest parts of the plastic mold, right? Everything else given being equal. You don't want those weld lines. So what did I do just now? If I'm filling in from that back end, and I do this analysis, I just saved 1 month of making the mold, making the first test part, finding the weld line, and redoing the part. Okay? Here's a picture of, they also call them knit lines if you do a Google search. Here's a picture of some knit lines where someone didn't do that. So what are we saying? And we're about 2 minutes from being wrapped up. What are we saying? What should we check for? Weld knit lines. They make the part weak, visually unappealing. Air traps. Okay? They're the oh, I go back. I got to show you this. Just because I got the simulation already. So here's the simulation in SolidWorks. These purple balls are air traps. It's where the air is stuck as the plastic runs toward it. Not a big deal here because it can vent to the top of this split parting line here. This one's a big deal, right? There's no place for it to vent to. It's too low. Same thing over here. No place for it to vent to. So Al, do you know how diesel engines work?
Yep. Pressure and heat.
Why don't they need spark plugs in diesel engines?
Because as the pressure rises and the heat increases, the explosion occurs.
Exactly, right? The spark starts just by the pure compression of the air-fuel mixture. That's what's going to happen at this spot right here. That's why they call it dieseling when you get these burn marks on injection mold. All right? If there's no place for the air to vent to, it's going to be just like a diesel engine. The plastic is the piston. There you go. There's your dieseling. All right? So what are we checking for? Possibility of burn marks, dieseling. Long cooling times. Waiting for it to cool is 70% of the mold time. If you want your parts to come out faster, you want them to be cheaper, maybe more easy to make, check for the cooling times. So what are we saying? You're not going to become a mold engineer using this product, but I say use this like a spell check. Just before you send something to the molder, just do a test like this real quick, maybe 2 or 3 on different scenarios. Use it as a spell check to catch those embarrassing mistakes, those simple mistakes. Your whole process will run a lot faster. That's what we're saying.